what's happening is it's a clue for us to do something else. Means there are two ways to iterate through a list. There are actually a couple of ways. The most famous ways what we do is we use a looping method to iterate over a list. Like for I in range of the length of this list, or for I in this list something. Or you can always do this popping. It means, for example, if you try to iterate over a loop, what I have to do, so ABC, let me declare it again. So it's actually a good thing that you're asking, even though, I mean, we have discussed it. So because we discussed only pop, not the extensions of it, because I don't really understand you're listening or not. So I did not discuss anything much in detail. So for example, if you have to iterate over for I in ABC, print I like this, it's a forward iteration. So for example, while the length of ABC is greater than 0, ABC dot pop, if you do it, okay. This is nothing but our reverse iteration. You got it right. So what is the advantage of these two? I mean, what is the advantage of this pop using it for iterating through the elements when compared to a normal iteration that you do using a for loop? This actually people don't explain in detail because again matters, real-time experience matters, right? So whenever you're popping up an array, it means you're removing each item, right? So it means the weight of the value that you're holding in your list decreases by every iteration. So it just frees up the space. Got it right?
Yes.
It's about more or less like what a pop in how it is used. Yeah. Today we're going to before we going to discuss about other data types. Give me 1 minute here. Just a minute. Yep. So I was saying before we are going to discuss about the other data types, we need to make sure you understand till this comfortably. So the methods you're using, the options, stuff like that, you're okay with this, right? Till now, whatever we have discussed.
Yes.
Yes.
Okay. Yeah. So the next thing that we are going to deal with is tuple. I'm really sorry. Just give me 5 seconds. Yep. So we're going to discuss about tuple, dictionary, set. So these are some powerful data types in Python, which actually makes our things easier. And like I said previously, there are some basic data types, and there are something called composite data types, which are as part of collections for every language. But fortunately, we have those composite data types embedded in inbuilt data types of Python. For example, there's something called hash map. When you speak about hash map, um, the storage happens like this. It will be key value pairs, but then the storage will be like hash. It means hashing technique will be used to store the values. Hash buckets will be created. For example, if you have some A, B, C, D, like 4 hash buckets, you'll have some hash value, and then for every value that you enter, it will be hashed up, and that hashed up value will be called as will be stored in that A or B or C or D. Whenever you perform hashing operation for a certain value for an input, you will either get A or B or C or D. Depending based on that, you'll store that value. So this hash map implementation is used for efficiency purposes. So this is by default it is available inside Python, that we call it as dictionary. So that's about a brief about that. We are not going to discuss about it. And now we first discuss about tuple. We discussed what a list is, right, and the operations that we can do. We clearly know that list is a mutable object. It means it can be changed at any time. Once it is declared, you can append, remove, pop, always do whatever you wish. But when you want to make your tuple immutable, when you want to make your list immutable, you can always do that, but we'll just rename it as tuple. That's it. So an immutable list is nothing but a tuple. So again, this is another interview question. Difference between list and a tuple. In which case, which is used? So basically, in general, if we have to say about this scenario, I mean, in what scenario a tuple is used, and what scenario a list is used. Both does the same operation, but we just log the data and we call it as tuple. So just blind spots for your interview experience. If you're actually with a valid experience in your hands, you can answer this one in this way. So for tuple, in general, we use for heterogeneous data types are involved in your data type. I mean, whatever your input is, if you're having some heterogeneous in the sense, if you have remember previous session, we spoke about lists. For example, there is something called sort. Sort can be performed under specified conditions where your data type should be homogeneous, right? So if you're having a list, string, and integer, or two different data types, your sort will not work. It will throw an error, an exception error. So basically, the whole context is we use tuple for heterogeneous data to iterate over it, and then list for homogeneous data in general, but it is not a hard stop for efficiency purposes again. And again, this tuple is well furnished for it is flexible for iterating over the objects. So it means always an immutable object is good for iterations. So iterating over a list takes a bit slightly delay, lag when it compares when you compare the iterating over a tuple. The justification here is because the tuple is immutable, it is locked in the space, and it is faster to iterate over it. So whenever a list is changed, you know how the index is allocated, right? It's a dynamic allocation. So it again needs to search for the ID of that particular appended element inside your list in order to find what it actually is. So it typically takes a bit of lag, but it is a bit of lag. You only understand the difference. It only makes sense about the difference when you deal with a huge amount of data. And again, I don't need to emphasize more on this. Whenever you're not changing your data inside your data type, only then you'll use tuple. Because we see a lot of times where we declare a list, we perform some logic, and then we modify the list. Append only in this case, or remove only in this case, like that. If you're having that kind of scenarios, definitely you should go for list. Makes sense, right? Yeah. And another heads up, we will be having tasks, as I've told you, right? So these sessions will be theoretical, and then the tasks I'll upload, I'll mail you guys in a while. Just please work on those. I'll not check those tasks at all, but maybe in Saturdays we'll have a session about those tasks. If at all you're lagging somewhere or something like that. I just got a heads up from Satish and I'm just sharing it. Yep. Where is my ID? So let us make this one. Set of ABs. I can just say it as this one. Let's see if it is a set or not. Again, I would like to point out this one. How do you know a data type is a list? It's an interview question. So are you actually noting down all these interview questions? Because I am not storing it anywhere. Please store it somewhere.
Oh, okay.
Mm. So how do you know a variable is a list or a dictionary or something like that? Because there are a lot of complex scenarios where you get nested data for you. Maybe if you take scenario of dictionary. So a dictionary might be like this. Yeah. So it might be a set of dictionaries nested inside it where you need to iterate over them. So just don't get scared about this. This is a very easy logic to iterate to each and every corner of any data type. But still, maybe you can get something like this as a list, and then another list of such kind. Maybe with Jerry, like that. There will be some data types that are getting exchanged here. So the point is, like, this is a mistake here. It should be a string in the key. So the point is, whenever you are iterating through a complex data types or a nested ones, you need to know what data type you're parsing through. It may seem very simple for you, the logic in here, but when it actually includes a lot of data, it doesn't really seem to be handy to for you to say what it is. Let me show you an example. I'm not sure if I can find a proper example for you. Okay, this is actually a processed data, so it should be very clear. Sorry? Oh yeah. Okay, so that's about it. I do not have currently processed data, so I was not able to show you. But when I iterate over this, I definitely I have the need to use this type of an iteration. For example, if I need to iterate over a dictionary, let us say a dictionary, and then I want to iterate again inside this dictionary or be in some another dictionary if I say, but I'm not really very sure that whether it is a dictionary inside this dictionary because the data really looks complex. So in that case, what I would do is print id of b, sorry, print type of b. So that's what I would give when I execute it. It just gives out it is a dictionary or a list or something like that. Based on that, I'll just follow up with the code. So what I was asking is, yeah, how do you know the data type at any point of time? And what about this ID? Have you heard of this before? No? Yes. Any clue? We actually discussed this, right? The specific property of Python in storing the variables is it is actually getting an efficiency in it. So, for example, when you declare, okay, I'll just show you. So when a is equal to 2, b is equal to 4, c is equal to 2. When I get id of a, it's a storage location inside the heap, right? So when I get the id of b, it is another storage location inside your heap, whichever it is empty. So when I print the id of c, it basically gives the same storage location that a is having. So basically id is nothing but the storage space, the index of the storage space, right? Mm. So when you're having an allocation, consider this is a, this is b, and this is c. So it'll be like this and this are pointing to the same steep heap space, which is having some xyz, some xyz location in space, whereas this will be following some abc allocation. So by which means whenever there is another occurrence of a similar value in your logic, the same space is being hit, which means you practically store a lot of save a lot of space. So how do you check the storage value of your data types in heap? The answer will be id. And in order to get to know any kind of a function that is inbuilt, help. These are the three generic questions that were asked in interviews. Having said that, let's move on to this tuple thing. So like I said earlier, how did we declare the tuple previously? So whenever you have another list inside your code, you can just say it as set of that list, right? So if you see here, set underscore abc, what we have done, set of that list is nothing but a set. Let's change this one. Did we do any mistake here? Why is abc gone? Did we declare abc? So the representation here changes, right? By this we might have understood will be like this. Sorry, what I'm doing. I'm very sorry. So a tuple will be like this with parenthesis separated by comma. So a set will be like that. We'll come to set again. We need to discuss a lot before we come to set, how it is organized and stuff. So everything is same when it comes to tuple. When it comes to the data and the elements inside the tuple, how it looks and stuff. But the thing is, instead of square brackets, we'll be using the parentheses. So for a string now to embed inside it, for a list, so here goes. I also wanted to call this out, like this is also a continuous, like a memory allocation, like the list. When you declare your list for the first time, it's just a continuous allocation of adjacent elements. So let's now concentrate on what this tuple can do. So as I've told you earlier, there are only two operations that you can perform in your tuple. One is count and the other is index. No to emphasize on this, right? We have already discussed this earlier when it comes to list. So how do you iterate over the tuple? You don't have any choice of popping out and saving your iterations and saving the RAM space like that. Just we have saw in list, right? You don't have that option. You just need to go out in the regular fashion. So each element you can get it. So that's about the tuple. For example, let us discuss declare a sample tuple. This is an empty tuple. Let's declare a tuple with one element. So it looks like more or less the same way that you can do with the list, right? Now I have to emphasize on this more, because there is more like a list of, but given the fact that the operations embedded inside are a bit less. So coming back to sets, hoping that you're very clear in understanding when to use tuple and when to use list. Those 3 points are very important in the interview perspective. One is for iterations, and the other is heterogeneous. We use heterogeneous for tuples, homogeneous. This is about performance tuning. It's not a basic level question when it comes to heterogeneous and homogeneous. This, while you have a choice again. And then this one, the modification part. When you really don't need to modify your data type, it's always recommended to use tuple than list, because tuple takes list takes a lot of lag. It is actually hitting the index. So next comes set. Set is an unorganized way of storing elements. So what do you mean by that? It means, like I've discussed earlier, sorting techniques and duplication, removal of duplicates. These are some aggressive data structures that we implement to achieve efficiency in these two types. So for how a set operates is set and a function. If you have heard about these two, maybe in your SSC or maybe in your matriculation or interview, you might have undergone this. A function is nothing but range and domain will be there. if this is your domain, if this is your range, there are two qualifications that qualifies this relation to be called as set, where the domain should not be mapped twice to the range, and then domain should always be mapped entirely. This is a higher level stuff for defining a set. But what you can do with set is, um, the main thing how set operates is, whenever you have a heap and you declare a set, the elements that you give input to your set. For example, if you're declaring a is equal to 1 comma 2 comma 3 4 comma 5, so when you declare it in your list, this entire bulk will get stored in your stack. Same thing happens when you declare your tuple. But when it comes to set, so maybe set is equal to set of, let's see what happens. Do I have something here? Yeah. Yeah. So I've declared a list, print a. I've got this printed. So, well and good enough. I don't know what's happening. So first thing is, duplicates are removed. Print this one. So if you see here, uh, whatever you got, the output here is, it starts with Java, Maths, Python, English, right? So now it changes to Maths, Java, English, Python. Now it changes to Java, Python, Maths, English. So what do you understand by this is, let me do this thing now. So Maths, English, English, Maths, English, Maths, English, Maths, English, Maths, Maths, English, Maths, English, English, Maths. So it's like a randomized thing if you observe it clearly. That's why when I used 1, 2, 3, 4, 5 randomized occurrences, it was all random. We cannot expect how a set returns every value. So this is one property of set. It means the location of the elements inside your inside your set are not they cannot be tracked at all. So what is the advantage? Simply, the advantage of set is to remove the duplicates. That is one thing, and then we can perform all set operations. Set operations, in the sense, what can we do with this sets? Whatever you have done, your problems in your school grades and stuff like that. So let's see what can we do. Now, before that, let us just declare a set. So now it has become a set, right? So these are all the operations that you can do. If you see these things, intersection, difference, add, clear, you don't have to get a take an explanation, right? So basically what it does is, let me just roll this out. This one. So it doesn't have I mean, we don't need to actually give a explanation about it. We are running it from so long. And remove is another one. Let us remove 5. These are all self-explanatory, I believe. So is set a mutable or immutable? Since we are able to modify it, it is always mutable. And then if you want to use set as immutable a data type, yes, we can also use it as a immutable data type. There is something called frozen set. If you declare a frozen set, will not be able to use all those methods. So this is all some executed stuff that I discussed you previously, right? So whenever you declare a set, a Python tutorial, it is taking all the unique values and allocating it randomly. So when you declare each string, then again, this is not worth discussing. So frozen set is declared just like frozen set instead of set. That's it. So whenever we try to add some element in your frozen set, just like we did in your set, we get an error stating that frozen set has not been added. So that's about it. And what are the main things that we can do using set is like the SQL statements. While we are dealing with the data, most probably while we are dealing with the data analytics, we have to have a requirement where there are two tables and we need to take the common part of those tables. So we basically use intersection, right? Or maybe we use select star from table minus select star from table, or select ID from table minus select ID from table. That is nothing but difference. So we'll go ahead and see one example. I don't really use this one. I don't know why. I'm more of like acquainted for turning a list into a set. Um, let's just declare all the subjects that we get. Or some other or something else. So this is one way of declaring a set. Let's declare B as let's just wrap it up. So if you want to really do this minus operations, again, I just want to call this out that we are actually dealing with very less amount of data, sample one. But when it comes to the table, which is having some crores of records, this set is more advantageous. So believe me, it just gives you 10x times faster than your regular query. So let us assign some difference is equal to a dot difference of p print def. So what is happening here? When you do a dot difference of b, you're getting the elements inside your a which are differing with the elements inside b. So it is basically a minus b, right? So you want b dot reference, it is b minus here, and that's about it. And again, if at all you want to know about whether a set is really a subset or a superset, um, you have this is subset, is superset, always available. So what you can do is, because there is a difference, it is a Boolean data type, so it only returns true or false. Same goes with the subset, whether it is a subset or not. And if you want to do the intersection thing, so the common elements, these are typically in general functions that you use in sets. So where do you use frozen sets and sets, normal sets? It's pretty much similar to what you deal with lists and tuples. Set is in general fast, frozen set is faster. So because elements are locked in this scenario when it comes to frozen set. So you can do almost all set operations using this data type set. So it is the main idea of introducing this set. By the way, this set is introduced only after 2.4 version in Python, and the main idea about under this is to improve the efficiency of your data types of dealing with data. This gave our way of introduction to data analytics in Python. So this is the brick of data analytics, you can say. So that's about sets. Uh, any doubts in tuples, sets, or frozen sets? Just let me know. Or else we can just move to dictionaries, which will be the last data type of our discussion, after which our actual deep dive into scripting begins. Before we do that, I really want you to understand in depth of how and what data type behaves, where and what you have to use in which scenarios, stuff like that. Yeah, so about dictionaries, the storage background of dictionaries is like key value pairs. Each key is assigned to a value. So how do you describe a dictionary? Let's say a key value pair. One is me, two use, let's say three maybe, yep, four, let's say just a sample one. So it says that this is a dictionary. So what happens here is there is always a key and a value for each element in a dictionary. Key is a pointer for your value, and key is always unique. So the properties of dictionary, let me just bullet it out. A key value pair, key should be unique, value may or may not be unique. And then this value can have mutable or immutable, but key do not have an immutable one. It is always a mutable. Sorry, it does not have immutable data types, except for integer and string. So you cannot have tuple as a key in your dictionary. That's the summary, or a frozen set. And dictionary or a hash map, why is it used? So in order to increase your space efficiency and your search efficiency constantly, in such cases we'll use. But later point of time, there is a revolution in your source systems. Till a particular point of time, there is always some kind of domination in your source systems. Your source systems data is always framed as XMLs or YAMLs or maybe HTMLs. So typically this XML used to be one of the famous one because it's again a key value pair. And then the revolution that I'm speaking about is JSON. It's not been too many years, maybe it was about 3 years maybe, I'm not very sure, but since the inception of this JSON, which is nothing but JavaScript object notation, we call it as, all the source systems were changed to a JSON compatible one. It means the data will be in JSON format. Why does every system have to do that? Has modified its data. It means it's lightweight, easily traversable, search efficiency. There are quite a bit of factors involved, but with the introduction of this JSON, your source system's parsing of data is really very easier. So it's like I can interpret as this way: you're having a book and you're having an index. With the index in your book, it's always easier to fetch your wanted page or your wanted module in that book, or maybe the lesson, whatever you say. So the indexes are nothing but the keys here. The values are nothing but the content that you're searching for. And your indexes are always unique in your books, which is the same case here with the keys inside your dictionary. So that's about a brief introduction to Python dictionaries. So what you can really do with dictionaries when compared to whatever you're performing with the other data types like lists, tuples, or sets like that. So everything has its own like uniqueness. So when it comes to dictionary, when it comes to sets, it's about about the set operations like union, intersection, difference, finding out whether it's more or less like data analytics, data comparison. And when it comes to dictionary, it's always about finding efficiently your search mechanism and storing your values efficiently. That's it. So let me do. Yeah, we can use this. So please be wary of all these data types, because in our assignments, I'll not be providing you what data types you have to use. Just need to focus on those, because you can only get it when you can understand each and every data type perfectly. So yeah, so sounds good. We are having a dictionary here. So what this dictionary, how can we actually pass through this dictionary? So when I hit on like, yeah, so it means, as I've told you, when you want to traverse to a page, you need to find its index. So when you see the list, the indexes of those lists starts from 0 to 1 incremented value. And there's no concept of using an index here, because as I've told you. A dictionary is nothing but a hash bucket. If your hashing value is confined to only 6 values, no matter what you pass as an input, you'll find that output of your hashing algorithm to either A or B or C or D or E or F. That's it. When your output is A, your value will be stored in your A. For example, this gives us A. Your value will be stored in the place of A. So like that, the storage mechanism occurs. So there's no point in hitting the indices inside your heap and getting them. So let's try it out. What are you getting this? Unexpected EOF while parsing. So it's like a horizontal storage where, let's say for example, all these values are getting stored horizontally in this A. So there's no meaning of calling it as an index, because this index is, if at all it is an index, it is not storing a single value, right? So we cannot really access elements through indices. But this index will have a value. Okay, so this index, how is it able to store horizontally multiple values is when you hit on ID of Harry will get the same value, ID of Kiran will get the same value, ID of Shiran will get the same value. But we do not really know that Harry, Kiran, Shiran are having the same IDs unless we try, because this allocation is again depending on the hashing algorithm, which Python not discloses. I hope this is not getting out of the box. I hope you're clear with this. So we just put it in a simpler fashion. So how to traverse between these things? So like I said, A of 1 gives us the value. A of 5, let us say, it says key error in the sense the key does not exist. So which is the case here. And do not bother about the loop definitions here. We'll come back about it later. How do you traverse through the dictionary? For I in A, let's see how it happens. If you give this, it is only giving you 1, 2, 3, 4. In the sense, okay, let me change this to 20. So it is giving 1, 20, 3, 4. It means it is only giving you the keys, not the values. So if I ever want to get the values, so this is the way that I use to get the values. But what if I want to get everything in a combined fashion? Okay, fine. Before that, there's something called print a dot items. So if you say a dot items, it just gives dict dot items. And if you see here, what are these? Can I call these as tuples? Because to me, being a Python guy, whatever I know is whichever element I see inside single quotes is a string, whichever element I see inside double quotes is a string, whichever elements I see naked is an integer, provided again it should be an integer or a float. Whichever it is between this is a list, between this is a tuple. So keys and values are given as tuples. So in order to parse these tuples for I comma b, or maybe for key comma value in a dot items, print. You can now print anything. So this is because of this. So you got key space value. Maybe I should keep this like this. There's the tab. So you understood, right? So I can access anything. And does this dictionary have the operations like whatever we have in list? It'll be pretty much helpful for us, right? If we have, let's see. In order to remove a key, a key from this, let's see what happens. It says del of 1 is not possible. That's because you're not really mentioning what is happening here. Yeah. So what you need to do is you need to just mention the dictionary and the key inside it. That's what we did, right? What we did earlier. Oh, okay. We don't mention yeah. So our one key value item was removed, and basically it is deleted. When you use this del operator, remember that it will be freed. The variable will be freed. Again, we need to discuss this. The variables in Python, once they are freed, few of them are disconnected. It means permanently emptied out from the heap. Few of them are not. Even when you close your interpreter, when you close your the ideal or sublime or whatever you're using, some system variables will still be active, uh, occupying your heap space. And when you use this del operator, the other variable will be free. That's just FYI. And let's see, let's try it out. This one, what happens? I just really wonder. So what is really happening here? A list being created only with the keys. So your first point of iteration when it comes to dictionaries is keys. If you want values to be iterated, um, we can use this. What's wrong with this? Oh yeah, sorry. I don't know what's happening here. There should be. That's why I choose always this one, this guy. Just give me 1 minute. So it just gives you a. This just gives you values. I don't know why it's not work it out in Sublime. So this is how you access your values. If you want to make a list of all these values, maybe you can call some ABCs into this, and for I in a dot values abc dot append I print abc. So this is how you manipulate between the data types. So I want you to be more thorough on conversion of these data types. So it means you will always have a requirement to switch between these data types. So I hope till now so far so good about dictionaries too. So we can also search the elements in your dictionary. Maybe we can also use Boolean search in the sense, for example, your dictionary is this, right? So what I can do is the key one, if it is present in this dictionary or not. So it just gives true, false. Let's see this. So it is really checking only for case, right? So it is never bothered about values. Why is it not bothered about values? In the sense, values are always duplicated. If at all there are two values, it doesn't really know what to check, or because the point of contact when you speak about the dictionary without declaring a value is always a key. So this is too much for today, I think so. Any doubts till now?
No.
No doubts.
Are you so good so far with sets, dicts, tuples, and stuff?
Yes, but I still have to practice more. So yeah, once I.
Yep, I'll just do this one. I'm having the videos now. I'll just upload it in some time, and I will also, if I find time, I'll just give you the practice sets by tomorrow. Videos will
Okay.
be in some time.
Sure.
Sushanti, no more doubts, right?
Yeah, no doubts.
Sure. Then can we wind it up then?
Yeah.
Sure. So do we have class tomorrow? You said you have you're going somewhere for vacation.
No. I was in vacation,
Oh, okay.
so
Okay.
yeah, it was done. We will be having classes
Okay. Thank you.
from now regularly. Yes.
Okay. Thank you. Bye.
Thank you so much. Yeah,
Thank you.